Let's talk rolling resistance. Now, there's the equation for rolling resistance. Unfortunately, I can't do the subscripts on this program, but uh, the force due to rolling resistance, FRR, is equal to the coefficient of rolling resistance, CRR, times force due to gravity on the system. So I just put W to be lazy, meaning the weight of the bike rider system. So if we know the rolling resistance, if we know the coefficient of rolling resistance, we multiply that times the weight of the bike rider system, right? And that gives us the force of the rolling resistance. Let me explain by using this video the concept of rolling resistance and factors that may influence rolling resistance. So here I've just got a slow-mo of biking over the ground. And rolling resistance is the resistance to moving this bike forward. All right, let me go back. What you'll see as this bike tire, or as this wheel rolls over the ground, there's compression right here. Okay, there's compression. There's compression here. What's happening is this tire tube interface is being compressed at the leading edge of the wheel. At the trailing edge of this footprint of this tire, the tire tube is recoiling and returning energy to the wheel. If this tire compresses a lot, it may not have the ability to recoil as much, meaning you're going to have a loss of energy, meaning you're actually going to be causing a resisting force to this object rolling forward. If I pump this up really high, I'm going to have less compression here. I actually deflated my tire quite a bit just so we could see it here, but I really just deflated the front one. You can even see it on the rear one a bit here, but a little bit less. The amount of pressure in the tire will influence how much compression there is. And how much compression there is will ultimately influence how the tire behaves. The tire tube, how the tire tube behaves. As the tire tube compresses, a good tire / tube or combination system will recoil as much as it compresses. And that's a good thing. That would mean lower rolling resistance. A tire that does not recoil much will end up having a higher coefficient of rolling resistance and therefore a higher rolling resistance force. That means it'd be harder to roll this wheel forward. So the amount of compression is a function partly of the amount of tire pressure, as well as how the wheel is built that holds the tire on the wheel, and how wide the wheel is. And we've actually done some research on this, and it's actually really interesting. You can find a tire pressure wheel width that results in the lowest rolling resistance. It's coefficient of rolling resistance. If you can figure out the lowest coefficient of rolling resistance, you can figure out the least amount of rolling resistance force. If you can have the least amount of rolling resistance force, that means you need less propulsion force to move forward. Oh, and excuse my shoes here. These are just my old Hoka running shoes cut into these sandals. So just being lazy and not putting my bike shoes on. All right, now that's hard to see, this compression here. What I did is for my next video, I put a little board down. Now let's watch how the tire tube, and I'm talking tire tube because this setup, I have a tube inside the tire. There are tubeless tires and there's tubular tires. Tubeless means it's the same type of tire as this one, but there's no tube in it. For tubular, that is a combination of a tire and tube all sewn together as one product, and the wheel is built a bit differently for tubular tires. Right now, it's more common for tubeless tires to exist on bikes. I haven't switched over yet. All right, so let's watch what happens to the tire tube as the wheel hits this bump. Lots of compression. Easy to see that compression now. Lots of compression, but a little bit less, because again, I only deflated the front part of the tire. All right, let me go back to this part. All right, so now we can see that compression. That compression is a good thing. That means less vibration going up through the fork, ultimately up to the handles. We're actually doing some work right now on measuring how much vibration the bike frame is undergoing and how much the handlebars are vibrating based upon how much tire pressure there is and how wide the wheels are. But nevertheless, here's some compression. That's a good thing. That compression can actually help reduce rolling resistance as long as the tube tire recoils. So if it does not recoil, then this energy that it took to compress the tire tube will be lost and it will increase rolling resistance. This is a good thing. As I was saying, the compression is a good thing because if this tire does not compress, then the whole system needs to be lifted up the height of that bump. Okay, it has to be lifted up. And if it's going up, that means that we're directing a lot of force to lift the bike rider upwards, which makes no sense because we're trying to move forward. So if we ultimately put in a lot of tire pressure here, we would actually be lifting this bike up the height of that bump. That would be work done. That'd be rate of work done, which would be power. That would mean we'd be losing power to go forward. So rolling resistance can actually increase when this tire tube is too pressurized. In fact, let's go to the rear wheel. Not as much compression, which means this wheel and the rider needs to be lifted upwards. We're actually losing some ability to roll forward because there's more pressure in the rear wheel here. All right, but rolling resistance is a function of how well that compression recoils right there. And if it recoils perfectly, then we're going to have minimum rolling resistance. If it does not recoil nicely, then we're going to have a higher rolling resistance. That's why cyclists will spend a lot of money on good tires. These tires, these right here, cost about, I think it was $60 each tire. So that's $120 worth of tires for 2 wheels. And the advantage of having a really good tire is it has low rolling resistance, which means that the tire will recoil nicely, and I can have a lower pressure. I can glide over bumps. You can see this wheel does not lift up immediately right here because the tire is deforming around that bump. That's going to be a smoother ride. As long as I get my recoil, I'll have a lower rolling resistance and a comfortable ride. Okay, so rolling resistance is just illustrating that compression. Rolling resistance will also be happening even before that, this compression right here. And then the amount of recoil that the tire tube allow helps to reduce or to increase rolling resistance. Okay, so rolling resistance, CRR, coefficient of rolling resistance times the weight of the bike rider system. These numbers are really low, but they can accumulate to a lot of resistance over a long distance bike ride, like 100 miles or 112 miles. So cyclists will try to reduce rolling resistance by buying a good set of tires and by having a good set of wheels in combination with finding the right tire pressure to allow for optimum compression of the tire tube and recoil. Too low of a tire pressure will increase rolling resistance. Too high of a tire pressure will increase rolling resistance. Okay, thank you.